This question asks us to use a graphing calculator and an inverse matrix to solve that system of equations, to express that solution using fractions. So 4 equations and 4 unknowns. Doing it with row reduction is a remarkably tedious exercise, especially if you have fractions involved. Computing the inverse of a 4x4 matrix, also very tedious. Doing Cramer's rule, finding determinants of 4x4 matrices, also very tedious. So really, some sort of a way to do this with technology is probably the way to go. So we're going to go ahead and rewrite this in terms of a matrix. So let me quickly copy down the question. We have A minus 2B plus 5C minus D equals 9. We have 3A plus 4B minus 7C plus 2D equals -1. We have 5A plus B minus 4C minus 6D equals -2. We have 4A minus 3B plus C plus 2D equals 7. So we want to write this in terms of the form AX equals B. A, 1, -2, 5, -1. First row. Second row, 3, 4, -7, 2. Third row, 5, 1, -4, -6. Fourth row, 4, -3, 1, 2. That's matrix A. Matrix X is the variables, which will be A, B, C, D. And matrix B will be the numbers on the right side, which 9, -1, -2, 7. So the way we solve AX equals B is we recognize that X equals A inverse times B. If A inverse exists, now you may have a situation where A inverse doesn't exist. Whoops, not A, X equals A inverse B. X equals A inverse B. We can't divide. Normally speaking, you see AX equals B. If these are real numbers, you would divide by A. But multiplying on the left by the inverse is the way that we do this. So we're going to jump to the calculator and we're going to plug in matrix A, 4 rows, 4 columns. Plug in matrix B, 4 rows, 1 column. So second matrix, edit, 4 by 4. First row is 1, -2, 5, -1. Second row is 3, 4, -7, 2. Third row is 5, 1, -4, -6. And the fourth row is 4, -3, 1, 2. So there's my 4 by 4 matrix. I always like to check to make sure I put it in correctly. So I'll go to second matrix, A. And 1, 3, 5, 4 is the first column, -2, 4, 1, -3. Second column, 5, -7, -4, 1. Third column, -1, 2, -6, 2. Fourth column. That looks good to me. Now we're going to go ahead and put in matrix B. Matrix B are the answers. So what does matrix B look like? Matrix B, 9, negative 1, negative 2, 7. 4 rows, 1 column, 4 by 1 matrix. So second matrix, edit, matrix B, 4 by 1. And we have 9, negative 1, negative 2, and 7. 9, negative 1, negative 2, 7 looks good. Second quit. Now, what's my answer? We can check to make sure it's right if you'd like. Matrix B. Just to double check that we've inputted the numbers correctly. 9, negative 1, negative 2, 7. Now, what is our answer going to be? X. Remember, X is the matrix A, B, C, D. X is going to equal A inverse B. So what is A inverse B? Second matrix A is here. The inverse button is here. Times, if you want, or just write it next to it. Times second matrix B. And what do we get? A inverse B. A whole bunch of decimals. We would very much prefer fractions. If it's nice enough, it should be able to convert those to fractions. Sometimes the denominators are so large it's beyond the calculator's ability. But let's see if it can. So we go, that's not what I wanted. I want to go to math, that's what I want. Math, change to a fraction. So this takes the previous answer and changes it to a fraction. And notice what I have. So I'm going to copy that on the paper here. So previously we said X was A inverse B. X was the matrix A, B, C, D. X was the matrix A, B, C, D. Little a, little b, little c, little d, just so there's no ambiguity. A inverse B, 707 divided by 344. Then we have 589 divided by 344. Then we have 771 divided by 344. And finally, we have 36 divided by 43. So something reduced there. If you know something about Cramer's rule, pretty good chance that the determinant of A is 344. We can check that if we want. But that's what we think we have, right? We think A is 707 divided by 344. We think B is 589 divided by 344. 707, make sure that looks like a 7. B is 589 divided by 344. C is 771 divided by 344. And D is 36 divided by 43. It would be good to check your answer on the calculator, so I'm going to do that next. So this is where we are. There is our original question, and there are our answers. So I'm going to plug that into the calculator and see if they check. That's my goal. So let me do that. I guess I'm going to be stuck looking at it like this. Okay, so how am I going to do that? Back to the calculator. I'm going to take 707 divided by 344. I'm going to store that in A, store in alpha A. Then 589 divided by 344, store in alpha B. Next up, 771 divided by 344. Whoops, 344. Store in alpha C. And finally, we have 36 divided by 43. Store in alpha D. So I have A, B, C, and D stored in my calculator. Now, what were my original equations? So let's go back and take a look at that. What was the first one? A minus 2B plus 5C minus D. We hope that's 9. Let's check. A, whoops, something happened there. A alpha A minus 2B plus 5C minus D and we hope that equals 9. And it does. The next equation was 3A plus 4B minus 7C plus 2D. Quickly, 3A plus 4B minus 7C plus 2D. Gives me -1. That one checks. So far, first one checked, second one checked. Then we go 5A plus B minus 4C minus 6D should equal -2. (5A plus B minus 4C minus 6D is supposed to equal -2, and it checks. And we have one last one to check, 4A minus 3B plus C plus 2D. We hope that equals 7. You really should check all of them. So here we go. 4A minus 3B plus C plus 2D is supposed to equal 7, does it? It does. So they all check. So pretty good indication that what we've done is correct.